This is 10.3. So in a previous lesson, we had something like the square root of 9. And we know that the square root of 9 is 3. And one way to simplify this is to break it down into its prime factorization. 3 times 3. And this number is a 2. So we need 2 copies of a number in order to bring that out. So if I circle this pair and bring it to the outside, I get a 3 on the outside, and then there's nothing on the inside, which is essentially just the square root of 1, which is 1. So if I had the square root of 8, 8 is 2 times 2 times 2, and I'm looking for a pair. So I can bring out one set of 2's, and that becomes a 2 on the outside. And then square root of whatever's left is a 2. Okay. But what if I had the square root of negative 16? Well, the 16 will become a 4 in a square root. But is there a number that I can multiply by itself and equal negative 16? Well, if I did 4 times 4, that gives me a positive 16. So if I made one of them negative, is that going to work? It is negative 16, but it's not the same number times itself. So that is true. This equality is true, but we want these two numbers to be the same. So I need to put a negative there, and now it becomes a positive 16. So essentially, this is not real. There is no real number that satisfies that. Now we're going to bump up to third roots. What is the third root of 8? Well, 8 is made up of 2 times 2 times 2. And now instead of circling pairs, I'm going to circle triplets. So here is a triplet, and that comes to the outside, 2. And then nothing remains on the inside, so the answer is just 2. Okay. What about the third root of 27? So 27 is 3 times 9, and then that breaks down into 3 times 3. So we ignore anything that factored. I'm looking for triplets. Here's a triplet. So 3, third root of 1, which is just 3. Now, a weird thing happens with third roots. What if I make this negative? Is there a number times itself that is negative 27? Yeah, it's negative 3. So negative 3 times negative 3 is 9, times negative 3 is negative 27. So if you have a negative on the inside of a third root, then it comes out with whatever else you bring out. Okay? So square roots of negatives are not real numbers, but third roots of negatives are real numbers. What if I had a fourth root? Could I take the fourth root of a negative? No, that would not be real. What about a fifth root? Yes. So if the root is odd, the negative can come out. All right, so this first problem, 64 is 8 times 8, which is 2 times 4, which is 2 times 4, 2 times 2, and 2 times 2. Now I cross off everything that factored, and I'm looking for triplets. So here's a triplet, and here's a triplet. Okay, so this brings out a 2, and this brings out a 2. So 2 times 2 is 4. And the negative also comes out. So negative 4. And what was left on the inside? Nothing. Everything came out. So the answer is just negative 4. So negative 4 times negative 4 times negative 4 is the third root of negative 64. All right. So I need to treat this as the third root of 125 over the third root of 8. So 125 breaks down into 5 times 25, which is 5 times 5. And 8 breaks down into 2 times 4, 2 times 2. Now I'm circling triplets, because, oh, sorry, these are third roots. Third root of that is just going to be 2. Third root of this is going to be 5. So the numerator is a 5, and the denominator is a 2. Okay. All right. Negative fourth root of 16. Is that doable? Yes, but what if the negative was on the inside? Can you take a fourth root of a negative number? No. So the fourth root of negative 16 is not real. But this is just saying, take the fourth root of 16 and then change its sign. All right. So we break this down, 4 times 4. Break this down, 2, 2, 2, 2. Now I need 4 of them to bring one out. So I bring out a 2, but there's already a negative on the outside, so the answer is just negative 2. Okay. Can I take the third root of a negative number? Yes. So 64 is 8 times 8, which is 2, 2, 2, 2, 2, 2. I need sets of 3. So there's a triplet, and there's a triplet, and the negative also comes out. So negative 2 times 2 is 4. Okay. What if I had the fourth root of negative 243? No, that doesn't work. Right? So what number times itself times itself times itself equals negative? Well, there's no way to do that. So if they were all negative, then this number would be positive. If they were all positive, then this number would be positive. So that would have no real solution, not a real number. All right. Write the following as an exponential expression. So this is the third root of t to the first. When we convert it into an exponent, it's going to look like this. This number goes in the bottom of the fraction, and this number goes on the top of the fraction. So this would be t to the 1/3. Okay. What if I had the fifth root of x to the 4th? What would that convert into? Well, this number is the bottom of the fraction, and this number is the top of the fraction. So 4 and 5. Okay. So what if I went the other way? What if I had x to the 7 halves? What would that be in radical form? Well, it would be this, and this number goes here, and this number goes here. So this would be the square root of x to the 7th. But if this is a 2, we don't need to write it. Right? Okay, let's do one more. Y to the negative 3/5. They probably aren't going to do a negative. We won't. So that would be the 5th root of y to the 3rd. Right? Okay. All right, so what happens when we raise a base with an exponent to an exponent? We times this by that. So this is x to the 3 over 10 times 2 over 1, which is x to the 6 over 10, which simplifies down to x to the 3 over 5. Okay, let's do one more of those. So I'm going to multiply 5 over 8 by 4 over 1, which is x to the 20 over 8. Simplifies down to x, pull a 4 out of each of those, to the 5 halves. All right, that's it. If you need help, let me know. I'll help you out. Get to work.